Level 1 taught you the basics: variables, loops, functions, simple error handling. Level 2 is where a script starts looking like real software. Today we'll cover 5 Level 2 modules: arrays, string manipulation, regular expressions, best practices, and testing, and then watch every one of them show up in a single capstone script, a log monitor you could run from cron tonight. First up, arrays. Bash has two kinds: indexed arrays for ordered lists, and associative arrays for key-value lookups, and you'll lean on both constantly once scripts start tracking real data. You can declare an array explicitly, or just assign to it directly, and Bash infers the type. Each element gets an index starting at 0, and you pull one out with square brackets. The @ sign gives you every element, the pound sign gives you the count, and an exclamation point gives you the indices themselves. 3 expansions worth memorizing, because you'll type them constantly. Associative arrays map names to values. Think of it as a dictionary. Unlike indexed arrays, Bash won't infer one from a bare assignment, so you always declare it with $A first. Put it together and you get word frequency counting in a few lines. Loop over the text once to tally counts, loop over the keys once to print them, sorted by count. That's the pattern behind the log monitor we'll build later. Arrays give you structure. Next, string manipulation gives you the tools to clean up and reshape the text those arrays hold. Bash can do a surprising amount of text processing without ever calling out to sed or awk, all through parameter expansion, the curly brace syntax you've already seen with arrays. The pound sign gives you the length of a string, and a colon lets you slice a substring by starting index, optionally with a length the same colon syntax you saw slicing arrays. Percent signs trim from the back, pound signs trim from the front, and doubling the symbol makes the match greedy instead of minimal. That double pound trick at the end is the standard way to pull a file extension in pure Bash. A caret uppercase, a comma lowercase, and doubling either one applies it to the whole string instead of just the first character. No external tools required. And when you need to split a line into fields, setting ifs to a comma before a read command hands you 3 separate variables in one shot, exactly the shape a CSV or log line usually comes in. That covers reshaping known text. But real logs and user input don't come in a known shape. For that, you need pattern matching, which is where regular expressions come in. Regular expressions let you describe the shape of text instead of matching it character by character, and Bash gives you 2 ways to use them, through grep, and natively inside a conditional. The $E flag turns on extended regex syntax, so a vertical bar means or, a plus means one or more, and anchors like caret and $sign pin a match to the start or end of the line. Inside double square brackets, the tilde = operator matches a variable against a regex directly. No external process needed. Just remember the pattern itself has to stay unquoted, or Bash treats it as a literal string. Wrap parts of the pattern in parentheses and Bash fills in the Bash_rematch array each capture group in order. This is exactly how you'd pull the date, level, and message out of one log line without spawning awk. You can now find data and pull out its pieces. The next module is about making sure the script around that logic doesn't fall over the first time something unexpected happens. This module isn't about new syntax, it's about the habits that separate a script that works on your machine from one you can trust in production. 3 lines belong at the top of nearly every real script: exit on any error, error on unset variables, and fail a pipeline if any stage of it fails, not just the last one. Quote every variable expansion. An unquoted variable gets word split on spaces and expanded against file names on disk, which is exactly how a script quietly mangles a file named with a space in it. Run shell check against your scripts. It's a static analyzer that catches exactly this kind of quoting bug, plus dozens of other subtle mistakes, before they ever run against real data. And validate every assumption at the top of a function, failing loudly right away. Once those checks pass, the rest of the logic can trust its input completely instead of guarding against bad data everywhere. Following these habits makes bugs less likely. Testing is how you prove, automatically and repeatedly, that they're actually gone. Shell scripts are code too, and they deserve real tests. Bat's Bash automated testing system gives Bash a testing framework that feels a lot like any other languages. Each add test block is one test case. The run command executes your function, capturing its exit code into status and its output into a variable you can assert against here, checking both are exactly right. Run the file with bats itself and it reports pass or fail per test case, with a summary at the end, something you can drop straight into a CI pipeline or a pre-commit hook. Set up and tear down run before and after every single test, and giving each test its own fresh temp directory keeps one test's leftover files from quietly breaking the next one. You can assert on the failure path too, feeding bat input and confirming both the exit code and the exact error message are what you expect, not just that something went wrong. 5 modules, 5 separate skills. Now let's watch them combine into one script you'd actually deploy. Here's the capstone: log_monitor.sh scans a log file for warning, error, and critical lines, counts them by severity, reports the most frequent message, and exits with a non-zero status when anything critical shows up. This is the kind of raw log. It reads timestamps, a severity level, and a message, one entry per line. Nothing fancy, which is exactly why Regex capture groups are the right tool for pulling it apart. For every line, the same capture group regex from earlier pulls out the level and the message, an associative array tallies the count for that level, and one flag remembers whether anything critical ever showed up. The whole report gets built once, printed to the screen, and saved to a file at the same time with T. Then, if that critical flag ever got set, the script exits with status 2 instead of 0. A signal cron or CI can act on. Run it against the sample log and you get exactly that counts per level, the most common failure message called out by name, a saved report file, and a non-zero exit because of that one critical line. And the BAT suite covers it end-to-end: missing arguments, a clean log, a critical log, even confirming the report file actually got written, so this script's behavior is proven, not just assumed. That's arrays, string manipulation, regex, best practices, and testing coming together in one real script. Every lesson we covered is linked below in the order we walked through them. Go build something that would survive running unattended at 3 a.m.